Hello. So in the previous lessons, we started talking about hypothesis testing or significance testing. Now, hypothesis testing is based on the idea of looking at what we call a null hypothesis, which is essentially the assumption of what we think to be true. And then we also consider an alternative hypothesis, which is if the null hypothesis is, if we have enough evidence to think that null hypothesis is not true, well, what else could be true? And so today we're going to talk about the types of errors that could be made when we do a hypothesis test. Now, the language that we use to talk about errors is particularly tricky. So you'll probably want to pause this video periodically and listen carefully to the vocabulary and write this stuff down as we go, because the vocabulary is very important. And if you don't get the right vocabulary down, you're definitely going to get these questions wrong on tests. So let's take a look at the first question. We see here in medical disease testing, the null hypothesis is usually the assumption that a patient is healthy. The alternative is that the patient has the disease that is being tested for. Patient is said to test positive if the test indicates that the patient has the disease. Patient is said to test negative if the test indicates that the patient does not have the disease. So in this context, what is a false positive? Now, unfortunately, we're probably all familiar with the concept of a false positive and a false negative because of the pandemic. So take a minute and consider what is a false positive and what is a false negative in this context. Okay, let's see if you're correct. A false positive in this case is a healthy patient who tests positive for the disease. In other words, the patient does not have the disease, but the test says that the patient does. And so what's a false negative? Well, a false negative would be a patient that has the disease, but for some reason tests negative. So in other words, the patient does not have the disease, the patient has the disease, but the test indicates that the patient does not have the disease. So which mistake is more serious, a false positive or a false negative? Well, you can debate this, but actually it depends on the particular context. And so there really is no one answer in general that a false positive or a false negative is more serious. It really depends on several factors: the situation, the context, the cost, etc. So let's take a look at the next thing on the sheet, which is the chart that summarizes the terminology for the types of errors that can be made. Now, you see here that this is a two-way table of sorts. Now, what you see here in the columns, we have two possible situations. And we're talking about the truth of the null hypothesis. So H naught, the null hypothesis, can either be true or false. Now, if H naught is true, that means that there is no difference between what we observed and what we assume to be true. So to go back to the example that we discussed in class, you think you know 80% of the material, but you got a 75 on the test. So does that mean you know 80% of the material? Is 75 close enough to an 80? Close enough, no difference. That's the idea if the null hypothesis is true. If the null hypothesis is false, that means that there is some difference, a significant difference between what we observed and what we assume to be true. So in the example that we talked about in class, you think you know 80% of the material, but in fact, you got a 20 on the test. So that suggests that there's a significant difference between what you actually know and what you thought you knew. Now, if you look at the rows here in this table, there are two possibilities. You can either reject the null hypothesis, or you can fail to reject the null hypothesis. Now, remember, we never say that we accept a null hypothesis. We only say that we can fail to reject. And the reason for that, as we said earlier, is that you can never really prove that something is true. I mean, you're not God. There's no way for you to know for sure. So if you reject the null hypothesis, if you think about the language, and here the language is really important, the rejecting of the null hypothesis means you think that there is some difference. And if you fail to reject the null hypothesis, that means that you believe there is no difference. So we define a type 1 error as essentially a false positive. So let's take a look at the top left corner here, and let's note what a false positive means. A false positive means that we are essentially rejecting a true null hypothesis. So a false positive here means that you are rejecting a true null hypothesis. What does that mean? It means that there is no difference, but you thought that there was one. Now think about that. Think about that again. A false positive means there's no difference. Remember, think about a false positive in terms of a medical test. If the null hypothesis is you're healthy, you don't have the disease, there's no difference between between being healthy and what you actually are, but you think there is a difference. You think you're sick. Now we define the quantity alpha to be the probability of a type 1 error. We're going to come back to that in a later lesson, but that's something that you want to store away in your brain for now. Now, if you look on the lower right, we see here we see here a type 2 error. That type 2 error, you can kind of think of a type 2 error as a false negative. False negative meaning that you have a null hypothesis that's actually false, but you decide to fail to reject that null hypothesis. So you're essentially kind of keeping a null hypothesis that's not true, that's false. And so that's equivalent to thinking that there is no difference, but in fact, there is some. In fact, there is a difference. The null hypothesis is false, but for some reason you decide to keep it. Now, if you find this vocabulary confusing, you can pause here, rewind the discussion for this slide, or just take a few minutes and pause and just look at the vocabulary and just say it to yourself a couple of times, because it's really important at this point that you become familiar with the explanation of what a type 1 error is and what a type 2 error is. And you should feel comfortable kind of explaining this using the vocabulary that you see here. Now, you also see that the probability of a type 2 error is quantity that we call beta. And again, we're not going to worry so much about alpha and beta right now, but this is something that we're going to come back to later. And by the way, in case you were wondering, you do remember that in the last lesson, we introduced the concept of an alpha level. And some of you may be wondering, well, is the alpha level the same alpha that's used here for a probability of a type 1 error? And actually, the answer is yes. They do actually refer to the same concept, but we'll talk more about that later. So you can pause here and take some time to think about the vocabulary. Say the vocabulary, say these concepts to yourself out loud, write some of this stuff down, and then we can continue. By the way, here's a tip. Incorrectly failing to reject the null hypothesis, I like to write this word 2 with the Roman numeral 2 to help you remember that that is what we call a type 2 error. You will notice, by the way, that when we talk about type 1 and type 2 errors, we typically use Roman numerals to refer to these. We don't write the numbers 1 and 2 that you typically write in regular arithmetic. So let's summarize the way to determine what type of error is being made. So you start by stating the null and alternative hypotheses in context. And then what you need to do is you determine if whatever conclusion you reach, does it provide evidence, we say, in favor of the null hypothesis or in favor of the alternative hypothesis. Now, if the evidence is in favor of the null hypothesis, in other words, if it suggests that the null hypothesis is actually correct, then we would say that there's no change. In other words, we can kind of think of that as a negative and think of that as like a negative test result, right? If the null hypothesis is that you're healthy, a negative test result says, yeah, it looks like you're healthy. There's no change in your condition. Evidence in favor of the alternative hypothesis would be an indication of change. Something has changed. And so you can think of this informally as being a positive. And again, to make the analogy to a medical test, null hypothesis is that you're healthy, but something changed. Somehow you got some kind of sickness. And so that would be a positive test result. So in order to determine how some other information that you receive after that conclusion affects that previous conclusion, you see, if in order to determine the type of error made, you basically look at null and alternative hypotheses. Then you reach some kind of conclusion. And then some other evidence comes along that perhaps challenges that conclusion. And if that evidence challenges that conclusion, here's where you decide, well, okay, let's see what happens. If the original conclusion was positive, let's look at this first bullet point. If the original conclusion was positive, and then you have new information that contradicts it, then you get what we informally could call a false positive. That's why we put this in quotation marks. That formally, that is what we call a type 1 error. Now, on the other hand, if your original conclusion was negative, and then you have new information that contradicts it, that would suggest that the negative result that you got, and we're using the word negative informally, was in fact false. And a false negative, we think of that as the type 2 error. So again, positive I associate with the Roman numeral 1, negative I associate with the Roman numeral 2. And so we can think, again, of a false positive as incorrectly rejecting H naught. And so a false negative would be incorrectly failing to reject H naught. And remember, I'm going to use the Roman numeral 2 here to kind of help you remember that that's what a type 2 error is. So now let's take a look at the next question. Let's determine whether a type 1 or a type 2 error was made, and let's state the possible consequences of that error. Now, the consequences, again, whenever we get questions like this, you want to make sure that you consider that in context. So let's take a look at number 2. Published study found that patients who took a diabetes drug had an increased risk of heart attack. However, further research indicated that the earlier study's findings were due to chance. So, in order to determine whether you made a type 1 or type 2 error here, you first have to determine, well, what were we starting with? And so that is going to be, what are our null and alternative hypotheses? Now, before we said that the null and alternative hypotheses always had some kind of number involved. But in this case, because we're dealing with a more with a kind of more general context where we don't have any specific numbers, it's okay for us to kind of think about the null alternative hypotheses in a more conceptual way. So in this case, the null hypothesis and the alternative hypotheses are really described only with words, not really so much with symbols. So you can take a minute and see if you can formulate the null and alternative hypotheses. Okay, let's see if you are correct. The null hypothesis, remember, in general is going to be a statement of no change, no effect, no difference. So let's see if we can put that in this particular context. That would be the drug had no effect on heart attack risk. And let's emphasize this idea of the drug having no effect. So no effect, no change. on heart attack risk. So what would be the alternative? The alternative hypothesis would be that the drug, in this case, increased the risk of a heart attack. Now, we don't want to say that the drug had an effect because we can actually, based on the context here, be more specific about the direction of the change. And because of the context here, we would say that the alternative hypothesis is that the drug increased the risk of a heart attack. And we see that here. So, was this a type 1 or a type 2 error? Well, what was the original conclusion? The original conclusion was that patients had an increased risk of heart attack after taking the drug. So if that would be evidence in favor of the alternative. So let's see, if we have evidence in favor of the alternative, now let's use the informal language. Is that a positive or a negative? Wait, in favor of the alternative, that would be a positive. Remember, that's like saying that you were healthy, that would be the null hypothesis, but now you're not healthy, so something has changed. So in this case, we have a positive, quote unquote, positive test result. However, further research indicated that the earlier study's findings were due to chance. So we concluded originally that there was enough evidence to reject the null hypothesis, which makes it positive. But further evidence showed the opposite, that the drug didn't increase the risk of a heart attack. So we should have failed to reject H0. So that is a false positive. Now, if it's a false positive, that is a type 1 error. Now, what does that mean in this context? Well, a false positive means that we thought that the drug increased the risk of a heart attack, but actually that was not the case. And so essentially what that means is that we deprived people who could have benefited from this drug from getting help, because we thought that it would increase the risk of a heart attack, but in fact it doesn't. So that's a pretty serious consequence in this context. Okay, let's take a look at the next question. A soda company wants to launch a new ad campaign to promote its new soft drink. After surveying customers who watch the new and old ads, the company decides that the new ads make no noticeable difference in customer preference. However, another survey finds that the ads did convince people to buy the new soft drink. Okay. Again, first step is to determine the null and alternative hypotheses in context. So let's see. Wants to launch a new ad campaign, surveying customers. The company decides the new ad campaign. So null hypothesis would be that the ads make no difference, because we're focusing on the effect of the ads. So the null hypothesis, again, no difference, no change, no effect, nothing to see here. Just move along. That's what the null hypothesis is. So what is the alternative? That the ads increased customer preference for the soft drink. Now, again, the context is quite clear that the alternative has a particular direction. In this case, that the ads increased customer preference. And so what was the conclusion from this study? Did the conclusion provide evidence in favor of the null hypothesis or in favor of the alternative hypothesis? So let's see. After surveying customers, the company decides that the new ads make no noticeable difference in customer preference. So make no difference means that is in favor of the null hypothesis. So that means that we don't reject the null hypothesis. And so that would be informally what we would call a negative result. Now, remember, we don't say we're going to keep the null hypothesis. We don't say we're going to accept the null hypothesis. The language is that we fail to reject the null hypothesis. But what happens in this context? What happens is that we had another survey that finds out that the ads actually did convince people. So that negative result was in fact false. Because we thought that the ads didn't make a difference, but in fact, later data indicated that the survey, that the ads did make a difference. And so what type of error is that? Well, if we go through this step-by-step procedure to work this out, we can see that if we wind up with a false negative, that means that we failed to reject the null hypothesis, but we actually were incorrect in doing that. So we incorrectly failed to reject the null hypothesis. That would be a type 2 error. Yes. Now, what are the consequences of that? Well, they lost out on an ad campaign that really could have helped. And so that's a shame. Now let's take a look at the next set of questions. In each situation, state the null and alternative hypotheses, and then explain what a type 1 and type 2 error would be. Now, in this case, we do have some numbers here, so we can actually, unlike the previous questions, we can actually write null and alternative hypotheses using our notation and using more specific numbers. So let's take a look at number 4. In 1999, 55.1% of high school students in the US played on a high school sports team. Has this percentage changed? So take a minute and write the null alternative hypotheses, and be prepared to state the parameter in context as well. Okay, let's see if you're correct. P is the proportion of high school students in the US who played on a high school sports team. We're just going to copy this straight from the context. So the null hypothesis is that H naught is that P is equal to 0.551, and the alternative is that P is not equal to 0.551, because again, the question says, has the percentage changed? And so what would a type 1 error be in this context? So let's think this out. A type 1 error would be an error, would be a false positive, so to speak. So a positive would be a conclusion with evidence in favor of which hypothesis? The alternative hypothesis. And so a false positive would be that that conclusion in favor of the alternative is in fact incorrect. So that would mean in this case that, let's state this a little more precisely, that assuming that 55.1% of high school students in the US nowadays play on a high school sports team, which is copying this from the question, the type 1 error would be to conclude that this percentage has changed. And so really all we did here is we took the language of the alternative and we removed the number from it, because the 55.1 was kind of stated in our original assumption. And we just said that the percentage has changed. So really what we've done is we've taken this part, that P is not equal to, and put it here, that this percentage has changed. So what would a type 2 error be? Type 2 error would be to conclude that the percentage has not changed. And so we can copy the rest of the language here. And so a type 2 error would be talking about the null hypothesis. And so we would put that here, that the percentage has not changed. Let's take a look at another example. In 1990, the percentage of pilots licensed in the US held by women was 5.8% and was on the decline. Is this percentage lower today? So let's state the null alternative hypotheses in context. Okay, P is the proportion of pilot's licenses in the US that are held by women. So the null hypothesis H naught would be that P is equal to 0.058. The alternative would be that P is less than 0.058. And it's less than because if you read the context carefully, it suggests that the percentage was declining. So that's the direction that we're interested in. So a type 1 error would be an error in favor. It would be based on evidence in favor of the alternative. The alternative would be that the percentage has declined, but then the idea is that that would be incorrect. So again, assuming that the percentage of pilot licenses in the US held by women is still 5.8%, the type 1 error would be to conclude that the percentage has decreased. So what would be a type 2 error? Assuming that percentage of pilot licenses in the US held by women has decreased from 5.8%, type 2 error would be conclude that it has not changed. So here you see that we can here you can say that we can state the context from the original question, and we would emphasize here that the type 1 error indicates that the percentage has changed, in this case decreased, and the type 2 error would be to conclude that it has not decreased.